today, synthetic division. This is good news for you guys. Synthetic division is a great shortcut, much easier than long division. You should definitely use this instead of long division when it's available, but you can't always use it. So the first thing is you have to know when you can and cannot use synthetic division. You can use it when the denominator looks like this, when it has x, it can always be written in the form x minus some number c. C could be negative. Subtracting a negative just looks like adding, right? So in other words, really, it looks something like this, x plus or minus some number, okay? Plus or minus some number. X has to be to the first power, the coefficient of x has to be 1. If you don't meet those criteria, you got to use long division. You cannot use synthetic division.
2x.
Like, then it wouldn't work, right? So the first thing is, I just want you guys to vote with your thumbs up or down on some examples. You tell me, could I use synthetic division or not?
Yes.
Yeah.
Yes.
Thumbs, guys.
Yes, you can. First one, you can.
No.
Okay, what's wrong with this one?
X squared.
Okay, yeah. We've got an x squared.
You just can't do x squared. It's only x.
It's pretty much just x plus anything, or x minus anything.
So the answer is for that one. No.
Nope.
Yes.
Okay, how about the next one?
Yes.
Yes.
Yeah, we're good. That's fine.
No.
Oh, many problems. What's one problem?
X squared.
X squared. And then I got another x. So that's tons of problems. No go. How about that one?
Yep.
Yeah.
Nope.
Oh, no.
What's the problem?
2x.
2x, yes. Okay, the fact that we have a 2 there is telling us no dice, right? Can't have a 2 there, it has to be a 1. Okay, so now that we know when you can and can't use it, how do you use it? Very simple. Here's how you use synthetic division. You set up a bracket like this. Now, it's a synthetic process, which is good news. Synthetic in math means only numbers, no variables. You're not, there's no, like in long division, you got all those x's that are in the whole process. There are many possible places to make mistakes in long division, I think, right? It's a fairly long process. When you get good at this, which means you have to do it about 2 times to be good at it, it's so simple. You'll be able to do problems like this in like 20 or 30 seconds. And, that's instead of 5 minutes for long division. I mean, it takes a while to do long division, right? So you're going to love this when it works. Does it work here? Yes or no?
Yeah.
It does. Good. So what do you do? Okay, very similar setup to long division, only the process is way easier. So the first row of coefficients comes from the numerator. The polynomial has to be in standard form, which it is, right? It has to go from biggest power of x down to the constant. And just like in long division, we have to have a column for every power of x, starting with the biggest, which is 4, and ending with the constant, which is x to the 0, right? So going all the way from the highest power down to the 0 power, meaning the constant. So what are those coefficients? I have to just write the coefficients. In my bracket, I've got room for 2 rows. The top row is going to be the coefficients of the numerator. What are they? What's the first one? What's the coefficient of the first term, the biggest power of x? 1, right? It's 1x to the 4th. So I get a 1. And I'll just put a little arrow. So this guy's going right there. What's my next coefficient?
2.
Oh, wait, would you put 0?
0. How come?
Because there's not the x to the
Okay, because I'm missing an x cubed. Exactly. So I need a 0. Because there's a 0 x cubed, right? We're missing that. Okay, what's my next coefficient? 2.
Negative 2, is it? No.
Nope.
Oh.
2.
Oh.
So it's coming, and that one's coming from here.
No, I thought you wanted to.
No, you're good, Keith.
Okay, next one.
Negative 2.
Negative 2. And then
negative 1.
negative 1 is my constant.
So,
And beneath the constant, we're always going to put a box under the bracket. If you had to make a guess right now, what do you think is going to end up going in that box?
the denominator.
The remainder, exactly, because we put a box for remainder here, just like in long division. right? That's the remainder box, okay, good. So there's first step. The coefficients go in the top row. Next step, we're gonna put a number out in front that comes from the denominator, but the number that goes out front is not -2. The number that goes out front is the 0 of the denominator, meaning the value of x that makes the denominator 0. So what is that?
2.
2. It's always going to be the opposite of the number that shows up with the variable, right? That makes sense? So if it's x minus 2, then the 0 is positive 2. If I have x plus 5 on the bottom, my 0 would be -5, right? Okay, so we get positive 2. And now we get to do this process. Very easy. The process is this. You kind of start the process rolling by dropping the leading coefficient down below the bracket. Every time a number falls below the bracket, you always multiply it by the outside number and add the result in the next column, okay? So what's that mean here? 1 times 2 is 2, plus 0 is 2, okay? I got a new number below, so what do? Multiply, which gives me plus 2 is 6. Notice I'm adding instead of subtracting, so we do the opposite of long division. Long division, we subtract vertically. Synthetic division, you add vertically. Okay, so I got a new number, so what goes there?
12. 10.
Which adds, so that column adds to 10.
And then 20, so it would be 20 there. That'd be 19.
So this becomes, my remainder becomes 19. Okay.
Whoa.
Okay, so then this, what you get below the bracket represents the answer to the division problem, right? When we divide the polynomials, this is what we get. Think back to when we did long division. We always got 2 parts to our answer, right? We got the part that sat on top of the division bracket, which was the polynomial part of our answer. And then we got the part that came from the remainder. We got a fraction that came from the remainder, right? Same thing here. So when we write down our answer, at the very end, we know we're going to get our remainder, which is a fraction. So 19 is my remainder. That goes in the top. What does the remainder always remain over?
X minus
So let's do
2.
the denominator.
Okay, the original denominator. Good. So it remains over the x minus 2. Okay, what about this other stuff? Well, these are just the coefficients in the polynomial part of our answer. Okay, so now how do you know which number goes with which power of x? The easiest way to do that is to start with the smallest, which is always the constant, right? The last term before the remainder is the constant in our polynomial, agreed? From like when we did long division. So then we know we're going to get a plus 10 at the end. What would the next biggest power of x be? X to what power?
X.
X to the first, right?
X.
Because this is our constant.
Oh,
So
yeah.
that's our x term. So what power of x here?
X squared. X
How about here? If I kept going, that would be the 4th, x to the 5th, x to the 6th. But we stop, right? So that's as big as our polynomial gets. And so then what does that mean? So our polynomial part is 1x cubed, which we would just write as x cubed. Here, I'll scoot up a little bit. Plus, that's a positive 2, so I get plus 2x squared, positive 6, so I do plus 6x. That's a positive 10, so I go plus 10. And then I add my remainder fraction, and I'm done. Boom. How easy is that, right? Super
Way
easy.
easier.
So you guys walk me through real quick. Walk me through one of these where you call all the shots and you do one on the board.
Well,
And put a 6.
Okay.
No.
This one we'll do just
Before,
do.
no, wait a minute.
So what are my coefficients?
Well, right. Before, would it be easier if we?
6.
If we.
6 and negative 9.
No.
Oh,
Six.
shut up.
6,
No.
0, and then -9.
No.
Okay.
Let's do
I'm
a
saying-
0 first.
Would it be simpler to like call out the opposite of your denominator first to put it on the outside?
That's fine. You can. Whatever order you want to do it in. So let's do the coefficients first. I already started. So what comes next?
Johnny, shut up.
0.
Yeah, I'll do it.
Negative
You have a bowl with no curls.
Make him teach. Turn
Hey, here we go. What's next?
9.
-9. Okay. So now what number goes out front?
3.
Positive 3. Good.
I'm sorry.
Oh, yeah, yours is the opposite.
Oh, okay.
Yes. Okay, so then do the process. What's first in the process?
We got to drop the 6 down.
Okay,
6
Then
times
multiply
3.
it.
6 times 3.
So 18.
And
Put
then
18
add
bottom.
up.
18 times 3.
18 times 3 would
Which
be
is a good question with
36. No.
36 plus 18.
6 plus 18.
54.
54. 54, yeah. 54 plus 9.
Minus 9.
Minus 9, my bad.
It's 45.
45.
okay, so then you guys tell me, please, what is my answer?
Uh,
Your answer is 6.
No.
6x
6x
plus 18.
6x.
And then
Plus 45 over
45 over
X
x minus 3.
Oh, yes.
Yes.
Weren't we supposed to start from
Wait,
the
why is it not
backside?
6x squared?
Because the
because
18
drop
is
an X,
just normal.
Oh,
And then the
gotcha,
next
gotcha.
one is 8.
Right, so the first one to the left would be the constant, then coefficient of x, right?
Aren't we
Good.
supposed to go from right to left?
Well, I mean, you probably should. Just the only reason being, so like if you have a lot of numbers there,
You don't
it just you don't have to think too hard about what's the first power of x. Then you just start with the constant and just build powers of x to the left until you're done, right? Okay, go to the boards, do that one, please.
I got this, right?
This is mine. Hell no.
Okay, 9x squared. I'm sorry. That was an insult. I didn't mean to say.
So my math, no, don't.
No, the X.
Sorry, Blakey.
Oh.
Had to get it.
Now,
Okay, so it's the polynomial remainder theorem. There's your baker's dozen for you. The polynomial remainder theorem just says this. This is going to let us use synthetic division to do something that otherwise took us a little more time to do. So you get 2 for the price of 1. The polynomial remainder theorem is new. All it tells us is that if a polynomial is divided by x minus k, then the remainder that you get when you do that division is actually equal to the value of the function if I plug k into the function. The 0 of the denominator, if I plug that into the function, the value that you get when you plug that value in for all the x's is equal to the remainder when you do the division process.
Like on the last one when it was 17, we could put it in.
That would have been, exactly. Okay, so now this would make no sense to do if you were doing long division. It'd be easier just to plug in the values for x and, like you've always done in the past. But if you have the access to synthetic division, which we do, right? If we're just plugging a number in, that's the number that goes out front. The synthetic process is actually easier than plugging a number in for all these x's and adding up the terms. And the reason is, when I plug values directly into a polynomial, I have to exponentiate and multiply and then also add terms. The exponentiation is the part that sometimes is kind of painful. If you're plugging in big numbers into a polynomial, when you take big numbers to powers, that explodes pretty fast and you get really big values that you have to add and subtract, right? So with synthetic division, all you ever do is just multiply and add. You don't have to do any exponentiation, right? So what's this telling us then? If I want to know what P of 4 is, then all that's telling me is that the number that I'm plugging into the polynomial is the number that goes in front of the synthetic bracket. Everything else is the same. What would the coefficients be?
1, 2, -3, 7.
Okay, and then I can do this process really fast. If I do the synthetic process, what do I do first?
1, 4, 6.
1 times 4 is 4, plus 2 is 6, times 4 is
24.
plus -3 is
21. 21.
times 4 is
21, 40, 88. 84, sorry, 84.
okay. Add those up and I get
91.
done.
What?
Okay, right? That's pretty
so,
good.
So it wouldn't be like you go 91 over 91 plus whatever the number was.
Well, so I mean, the alternative would have been to plug 4 in for all those x's and take all those powers and add up the terms. That's harder though. It involves more computation than just this synthetic process. And so what we find is that synthetic division you get that baker's dozen effect here. You get synthetic division also gives you synthetic substitution at no additional cost. It's the same process. You're just interpreting it a little bit different, right? Synthetic substitution, or sometimes people call it synthetic evaluation. So you guys try one of these. I want you to do one where here's your polynomial, here's p of x. You're going to plug negative 2. You're going to plug negative 2 into the function using synthetic substitution.
Is that what you just